Loops are so great, they are so useful, that processing gives us two different ways to think about them and write them. In a previous video, we saw the while loop, and in this video, we'll see the for loop. One thing to keep in mind is that either loop can do everything that the other one can do. It's really just two different ways to think about and write the very same information. To get started, let's do a quick recap of the while loop. This is my view of kind of the structure of a basic while loop. Before we begin, in green, there's an initialization statement. Often that means setting some variable to a starting value. Then we have the while loop itself, which consists of the word while and a test in parentheses. As long as the test is true, we do the statements that are enclosed within curly braces, and one of those statements here I'm calling update. And typically, that means we're going to modify some variable that eventually will cause the test to become false and end the loop. Now let's see how to write this in the for style. The for loop has this generic starting structure: the word for, an open parenthesis, and then there are three slots that are separated by semicolons. Then there's a close paren, and it's followed by the statements of the for loop. Like the while, the statements begin with an open curly brace. We have one or more statements and then a closing curly brace. The three colored statements in the while loop go into the three slots of the for loop. The init goes into the first slot. Often this means setting the starting value for some variable, like y equals 0. The test goes into the second slot. Notice that we don't need parentheses around the test in the for loop. That's because the test is kind of automatically set off from the other statements by the two semicolons that surround it. Finally, the update step goes into the third slot. That's the basic syntax for the for loop. Let's take one of our examples from the while loop video and rewrite it in this style. Here's a little program that drew 6 circles spaced out horizontally on the screen using a while loop. We're going to rewrite this as a for loop. Well, a lot of the stuff just comes over unchanged. The basic variables that tell us where the circle is, how many of them we want, and the two lines that draw the circle and cause the center of the circle to move to the right. That all stays the same. What we're going to change is the loop stuff, and we're going to do a for loop, so let's put that generic for loop placeholder in there. So we've got the word for, the open paren, the three slots, they're separated by the semicolons, close paren, the open curly brace, we have our statements, so we put a closed curly brace at the end, and we know what goes into the three slots. There's some kind of an initialization statement, some kind of a test, and then some kind of an update. So to get things started, I'm going to want some variable that's going to count how many circles we have drawn. In the while example at the top, I'm calling that drawn circles, which is a great name, but it's a long one. And in the for loop, it's going to appear several times. And so if I wrote out the full word drawn circles, the line would just become very wide, and I'd have to use a smaller font, and it would be harder for you to read. So in the interest of keeping my fonts big, I'm going to change the name drawn circles just to the letter I. So in the line above the for loop, I'm going to create a variable to count the number of circles we've drawn, and I'm simply going to call it I. So there's my integer. Now that we have I, what is its starting value? Well, we put that into the initialization step. We'll set I equals 0. That takes care of getting I started. Now we take a look at the test. We're running a loop, and we want to compare the value of I with num circles. So our test is I less than num circles. Finally, we have the update. And in this case, the update is we want to add 1 to I because we've drawn one more circle. So let's go ahead and put I++ in there. And this now is the for loop version of the while loop that we saw above. These two nuggets of code do exactly the same job. It's just a different way of writing it and a different way of thinking about it. Whichever one you prefer is perfectly fine. You'll typically see more for loops than while loops because the for syntax lets you jam everything together into one line rather than 3 separate lines. So you save a couple of lines of code. Aesthetically, that's nice. It's usually a little bit faster to type, but there's no difference in terms of how quickly the program runs or how efficiently it runs. So really, you simply choose the version that best matches the way you're thinking about the problem and is most convenient for you. To lock down how the for loop works, let's go ahead and step through it and see what happens. So here's the loop we just wrote. I added one line at the bottom just to print all done so we know when we're finished. At the bottom, I will draw our graphics window with a little ruler at the bottom, just like we did in the while case, so we can see our graphics getting drawn. And also, like in the while case, I will track the values of our variables in these three boxes in the middle. In this case, the three variables we care about are num circles, I, which is our loop variable, and circle x, which is telling us where each circle is horizontally. So let's step through the code as though we were processing and see how it draws the 6 circles. As before, this orange arrow tells us which line we're about to execute. So this line says circle x equals 100. No problem. We'll stick 100 in there. And now we move on to the next line. Num circles is 6. Great. We'll stick a 6 in there. Next line, we declare the variable I. It doesn't have a value yet. Now the for statement. The first thing that happens is we do the initialization step. I equals 0. Great, so we just execute that and we stick 0 in I. Now we do the test. Is I less than num circles? Well, 0 is less than 6, so this is true. So we go into the loop. We draw the ellipse. Then we do the next line, which just adds 100 to circle x. So let's go ahead and do that. And now we hit the closing curly brace. We're done with the loop. It's time to check again. So we go back up to the top of the loop, back to the for statement, and now we execute the update. The update comes at the end of the loop before we test again. So I is the value 0. Now we'll add 1 to it and make I 1. Great. Now we check the test. Is I less than num circles? Well, yeah, 1 is less than 6. So we go into the ellipse, we draw the ellipse, we go to the next line, we add 100 to circle x, we go to the next line, that's the closed curly brace. Back up to the top we go. And as you remember, the first thing we do is the update statement. I is currently 1, so I++ adds 1 to that, and now I is 2. Now we do the test. 2 is indeed less than 6, so into the loop we go. We draw the ellipse, we add 100 to circle x, and we're at the bottom of the loop. So our job is to go back up to the top. Well, you get the idea. This goes around and around. So let's jump to the last step. We've now drawn 6 circles. So num circles is still 6. Circle x, which tells us where the next circle will be drawn, has made its way up to 700. And the value of I is now 5. We're at the last line of the loop. So as always, we go back up to the top. We're at the for again. First thing we do is we do the update step. We add 1 to I. I goes from 5 to 6. And now we test that against num circles. 6 is not less than 6. So the test fails. We jump to the end of the loop and we do the first line after the loop. We print all done and we're finished. The key thing to keep in mind with the for loop is that the first time you hit the for loop is different than all the following times. The first time you enter the for loop, we do the initialization step and then the test. Every time we return to it, we do the update step and then the test. Well, that's really all there is to for loops, but there is one extra little convenience that has been built into for loops that you don't have to take advantage of, but almost everyone does because it is a great convenience. Here's a tiny little fragment of code. First, I declare a variable I, and then I use it in a for loop. Well, it turns out that in a for loop, if you want, you can actually declare a variable in the init statement. That first statement, you can put int I equals 0, and that combines the declaration and the initial value assignment. It's just a tiny little shortcut. It's a feature of for loops. And you can stick that thing in there, and people do that all the time because it saves you a line. And that's all it is. It's just a way to not have to say int I above. It's very convenient. And if you look at other people's code, you'll see people do this all the time. So again, to compare the two, at the top we have the while statement. The initialization comes first, then we have while with its test, and in the body of the loop we do an update. And notice I've written the update as the last statement. That's to make it match up with the for, which is below. The first time we hit the for loop statement, we do the initialization and then the test. We do the statements, and then we come back to the for loop, and now we do the update and then the test. And each time we return to the loop while we're looping, we do the update and then the test. Both of these forms of loops do the very same work. Whichever one you choose for a particular part of your program just depends on which one seems to fit the way you're thinking most conveniently.